Hello everyone, today we're going to talk about the very famous knapsack problem and its implementation. So let's get started. So in knapsack problem, we are given a set of items and each item have a weight and a value. We have to determine which items we should include in the collection so that the total weight is less than or equal to a given limit and the total value is as large as possible. So we are trying to maximize the total value that we can get. So here we have a knapsack of capacity 15 kilograms and we have 5 items. So this green item have a weight of 12 kg and it will give us a value of $4. Then this blue item have a weight of 2 kg and it will give us a value of $2. Then this gray item have weight of 1 kg and it will give us a value of $2. Then this orange item have a weight of 1 kg and it will give us value of $1. Finally, this yellow item have weight of 4 kg and if we include that in knapsack, it will give us a value of $10. Now we have to figure out which items we should include in this knapsack which have capacity of 15 kg so that we can get the maximum value which is possible. Now, if we have any number of each item available to us, then we will take 3 yellow items, which will give us total value of $30 and weight of 12 kg. So we have still 3 kg left. Then we will take 3 gray items, which will give us total value of $6. So 12 plus 3, which will be 15 kg. So the total weight will be 15 kg and the total value we can get is $36. So if we have any number of each item available to us, then we will take 3 yellow items and 3 gray items, which will give us total value of $36 and total weight of 15 kg. But if we have only one quantity of each item available to us, then we will take all items except this green item. So in that case, we will get total value of $15 with total weight of 8 kg. Now we will be considering the knapsack problem where we have only one quantity of each item. So we cannot include the same item more than once. So we will be considering the second case. Now let's talk about what we mean by 0-1 knapsack. So in 0-1 knapsack, items are indivisible. We cannot break an item. Either we take the whole item or we don't take it. So we cannot take the fraction of an item. This is called the 0-1 property and we will be considering the 0-1 knapsack problem. So here we have 3 items with their respective weight and value and the total capacity of the knapsack is 5 kg. And we have to figure out which items we should include in the knapsack so that we can get the maximum value that is possible. Now to get to the solution to the actual problem, which is given above 3 items, what is the maximum value that we can get when total capacity of the knapsack is 5 kg? We will first solve the subproblems. So let's see what those subproblems will be. So given only the first item and the total capacity of the knapsack is 2 kg, what is the maximum value that we can get? So the answer in this case will be 0 because the weight of the first item is 4 kg and we have a knapsack with capacity 2 kg. So we cannot put the first item in the knapsack. So the value in this case will be 0. Now given only the first item and the total capacity of the knapsack is 4 kg, what is the maximum value that we can get? So the answer in this case will be 10 because the knapsack capacity is 4 kg and the weight of the first item is 4 kg. So we can put the first item in the knapsack. So the maximum value that we can get in this case will be $10. Now given only the first 2 items and the total capacity of the knapsack is 5 kg, what is the maximum value that we can get? Now since the knapsack capacity is 5 kg, we cannot include both the items because if we do that, the total weight will be 6 kg, which is more than the knapsack capacity. So we can only select one of these 2 items. And if we select item 2, we will get the value $4. But if we select item 1, we get the total value as $10. So we will include the first item in the knapsack, which will give us the value as $10. So answer in this case will be 10. Now given all 3 items and the total capacity of the knapsack is 3 kg, what is the maximum value that we can get? Now we cannot include the first item because its weight is more than the knapsack capacity. So we can only include either item 2 or item 3. Now if we include item 2, we get the value as $4, but if we include item 3, we get the value as $7. So we will include the item 3 in the knapsack. So that's why the answer in this case will be 7. Now we will see how we can use the result of these subproblems to get to the result to our actual problem. And we will be solving the 0-1 knapsack problem using dynamic programming. And to be specific, we will be using the tabulation technique. So we can represent the problem using a two-dimensional array where rows represents the items and the columns represent the knapsack capacity. So this row represents the solution to subproblems when we don't consider any item, and this row represents the solution to subproblems when we consider only first item, and this row represents the solution to subproblems when we consider first two items, and this row represents the solution to subproblems when we consider all three items. Similarly, this column represents the solution to subproblems when the knapsack capacity is 0. And this column represents the solution to subproblems when the knapsack capacity is 1. And this column represents the solution to subproblems when the knapsack capacity is 2. And finally, this column represents the solution to subproblems when the knapsack capacity is 5. So the value in this cell represents the maximum value that we can get when we have 3 items and the knapsack capacity is 5, which is our actual problem. And value in this cell represents the maximum value that we can get when we have only first 2 items and the knapsack capacity is 5. Similarly, value in this cell represents the maximum value that we can get when we have only first item and the knapsack capacity is 4. And the value in this cell represents the maximum value that we can get when we consider all 3 items and the knapsack capacity is 2. Now to know the value in this cell, we will be first solving simpler subproblems, and then we will use the result of those subproblems to get to the result of this problem. So all the values in the first row will be 0 because this is the case when we don't consider any item. And since we are not considering any item, regardless of the capacity of the knapsack, all the values in the first row will be 0. Similarly, for the case when the total capacity of the knapsack is 0, we cannot put any item in the knapsack as each item have weight more than 0. So all the values in the first column will be 0. Now let's see what will be the values when we consider only the first item. So the weight of the first item is 4 kg and the value is 10. Now since the weight of the first item is 4 kg, we cannot include the first item when the knapsack capacity is less than 4. So when the knapsack capacity is 1 or 2 or 3, now in this case we cannot include the first item, so the value is 0. Now when the knapsack capacity is 4, we can include the first item, so the value is 10. Similarly, when the knapsack capacity is more than 4, we can include the item. So in that case as well, the value we will get is 10. Now let's see what will be the values when we consider the first 2 items. So we will be filling this row. Now the weight of the second item is 2 kg and the value is 4. Now we cannot include both the items because if we do that, the total weight will be 6 kg, which is more than the knapsack capacity. And since the weight of the second item is 2 kg, we cannot include the second item when the knapsack capacity is less than 2. So when the knapsack capacity is 1, the value is 0. Now when the knapsack capacity is 2, we can include the second item, so the value is 4. Similarly, when the knapsack capacity is 3, we can include the second item, so the value is 4. Now when the knapsack capacity is 4, we can include the first item or we can take the second item, and if we include the first item, we will get the value 10, and if we include the second item, we will get the value 4. So we will take the maximum value, which is 10, so we will include the first item. Similarly, when the knapsack capacity is 5, we will include the first item, so we can get the maximum value, which is 10. So we have solved many subproblems. So now we know that if we are considering the first 2 items and if the knapsack capacity is 5, the maximum value we can get is 10. Similarly, if we consider the first 2 items and if the knapsack capacity is 3, the maximum value we can get is 4. And if the knapsack capacity is 1 and we consider the first 2 items, the maximum value we can get is 0 because we cannot include any of those 2 items because both the items have weight more than 1. So the value in this case will be 0. Now we are getting closer to our actual problem, which is this one. So given the 3 items and the knapsack capacity is 5, what is the maximum value that we can get? Now let's see what will be the values when we consider all three items. So the weight of third item is 3 kg and the value is 7. Now when the knapsack capacity is 1, we cannot include any of these three items because each item have weight more than 1. So the maximum value that we can get in this case is 0. Now when the knapsack capacity is 2, we can include the second item, which will give us the value 4. So the maximum value in this case will be 4. Now when the knapsack capacity is 3, we can either include the second item, which will give us the value 4, or we can include the third item, which will give us the value 7. So we will include the third item because it will give us the maximum value, which is 7. Now when the knapsack capacity is 4, we can either include the first item, which will give us the value 10, or we can include the third item, which will give us the value 7. So we will include the first item because it will give us the maximum value, which is 10. Now when the knapsack capacity is 5, we can either include the first item, which will give us the value 10, or we can include both second and third item, which will give us the value 11. So we will include both the second and third item, which will give us the maximum value, which is 11. So we got the solution to our actual problem. So given these three items, and if the knapsack capacity is 5, the maximum value we can get is 11. Now let's see how solving subproblems helps us in finding the solution to the actual problem. And also there is one very important thing to know about the solution of this problem. So when we consider an item, we have two choices, either to include the item in the knapsack or not include the item in the knapsack. So we take the maximum out of these two cases. So this is the case when we don't include the ith item in the knapsack, and this is the case when we include the item in the knapsack. Since we are including the ith item in the knapsack, we will take the value of the ith item and we go to the cell which is one row above. And since we will be adding the ith item in the knapsack, we have to go to W minus WI column because we will be adding the weight of the ith item, where WI is the weight of the ith item and W is the capacity of the knapsack. For example, to solve the subproblem when we are considering only the first two items and the knapsack capacity is 4, now there will be two cases. So this is the case when we don't include the second item in the knapsack, or we can go to this cell and add the value of the second item, which is 4. So 0 plus 4 is 4. Now why we went back 2 columns? Because we will be adding the weight of the second item, which is 2 kg. That's why we went back 2 columns. Now the maximum out of 4 and 10 is 10. That's why we will store 10 at this cell. Now we only calculate this value when the weight of the item is not greater than the knapsack capacity. Because if the weight of the item is greater than the knapsack capacity, we know that we cannot include that item. So in that case, we simply take this value. So if the weight of an item is greater than the knapsack capacity, we cannot include that item. We have to exclude that item. For example, in this case, when we are considering all three items and the knapsack capacity is 2, we cannot include the third item because the weight of third item is 3 kg. So in this case, we simply copy 4 at this cell. Now let's see how the values in the cells are calculated using this formula. So we are going to calculate K21. Now since the weight of second item is 2 kg, so we can't even consider second item when knapsack capacity is 1. That's why K21 will be K11. So we will copy this value to this cell. So K21 will be 0. Now let's calculate K22. So K22 will be maximum of either this value, which is 0, or the value of this expression, which is 4 plus K10. So K10 is 0. So it will be maximum of 0 or 4. So we will take the maximum value, which is 4. So K22 will be 4. Now let's calculate K23. So K23 will be maximum of either this value or the value of this expression. So 4 plus K11. So K11 is 0. So maximum of 0 or 4. So we will take the maximum value. So K23 will be 4. Now let's calculate K24. Now K24 will be maximum of either this value or the value of this expression. So 4 plus K12. So K12 is 0. So maximum of 10 or 4. So we will take the maximum value, which is 10. So K24 will be 10. Now let's calculate K25. Now K25 will be maximum of either this value, which is 10, or the value of this expression. So 4 plus K13. Now K13 is 0. So 0 plus 4, which is 4. So maximum of 10 or 4. So we will take the maximum value, which is 10. So K25 will be 10. Now let's calculate K31. Now since the weight of third item is 3 kg, so we can't include third item when knapsack capacity is 1. So K31 will be equal to K21. So we will copy this value to this cell. So K31 will be 0. Now let's calculate K32. Now since the weight of third item is 3 kg, so we can't include third item when knapsack capacity is 2. So K32 will be K22. So we'll copy this value to this cell. So K32 will be 4. Now let's calculate K33. So K33 will be maximum of this value or value of this expression. So 7 plus K20. Now K20 is 0. So maximum of 4 or 7. So we will take the maximum value, which is 7. So K33 will be 7. Now let's calculate K34. So K34 will be maximum of either this value or the value of this expression. So 7 plus K21. So K21 is 0. So maximum of 10 or 7. So we will take the maximum value, which is 10. So K34 will be 10. Now let's calculate K35. So K35 will be maximum of either this value or the value of this expression. So 7 plus K22. So K22 is 4. So 7 plus 4, which is 11. So maximum of 10 or 11. So we will take the maximum value, which is 11. So K35 will be 11. So by using the result of simpler subproblems, we are able to solve our actual problem, which is when we have 3 items, when the knapsack capacity is 5. So the maximum value we can get is 11. So K35 will be 11, which is the answer to our problem. So we know that the maximum value we can get is 11. Now let's see how to know which items we included. So we will start with the last cell and we will compare it with the cell above. Now these two values are different. It means we included the third item. Now we will go 1 row above and 3 columns back. Now why 3 columns back? Because the weight of third item is 3 kg. So we will compare 4 with 0. Now these two values are different. It means we included the second item. Now we will go 1 row above and 2 columns back. Why 2 columns back? Because the weight of second item is 2 kg. Now the value in this cell is 0. It means we don't need to compare anymore. So we included item 3 and item 2, which gave us the total value of $11. Now let's see the implementation. So we have an app class, and in the main method we define the number of items and the capacity of the knapsack, and we have 2 arrays. So this first array holds the weight of items and the second array holds the value of items, and we pass all these values to the knapsack constructor, and then we call the solve method, which will return the maximum value that we can get. And we also call the show result method, which will print the items that we included. Now in the knapsack class, we have properties like number of items, capacity of knapsack, weights and values arrays, and the knapsack table, which is a 2-dimensional array, and the total value. And in the constructor, we initialize the properties. Now one important thing to note is the size of the knapsack table. So it will have as many rows as the number of items plus 1, because we consider the case when we don't include any item in the knapsack. Similarly, it will have as many columns as the capacity of knapsack plus 1, because we consider the case when the capacity of the knapsack is 0. Now let's see the implementation of the solve and the show result methods. So in the solve method, we first fill the value of the base cases. So this is the case when we don't include any item in the knapsack. So regardless of the capacity of the knapsack, all the values in the first row will be 0. Similarly, this is the case when the knapsack capacity is 0. So all the values in the first column will be 0. Next, we start filling the values from the first row and first column, where I represents the row and W represents the column. Now there will be 2 cases. So this is the case when we don't include the ith item. And if the weight of the ith item is less than equal to knapsack capacity, we can consider including the ith item in the knapsack. So this will be the value if we include the ith item in the knapsack. Now one important thing to note is we access the weight of the ith item as weights I minus 1 and the value of the ith item as values I minus 1, because array indexes start with 0. Another very important thing to note is that we calculate this value only when the weight of the ith item is less than equal to the knapsack capacity, and then we take the maximum out of these 2 values, and finally we set the total value as the value in the last cell in the knapsack table, and we return that value. Now in the show result method, we will start from the last cell. So n will be equal to number of items and w will be equal to capacity of knapsack. And if n is greater than 0, we will check this condition. So if the value is not equal to 0, and if the value at this cell and the value at the cell above it are different, it means we include this item. So we include this item and we subtract the weight of this item. Now the runtime complexity of this implementation of the 0-1 knapsack problem will be equal to big O of n into w, where n is the number of items and w is the capacity of the knapsack, because in the solve method we have a nested loop where outer loop is bounded by the number of items and the inner loop is bounded by the capacity of the knapsack. That's why the runtime complexity of this implementation of 0-1 knapsack problem will be big O of n into w, where n is the number of items and w is the capacity of the knapsack. Now let's execute the code and see the result. So this is the same problem which we discussed. So we have 3 items and the capacity of the knapsack is 5. So the answer in this case should be 11. So the maximum value we should get is 11 and we should include second and third item. So let's execute the code. So we got the total value as 11 and we included item 3 and item 2. Now let's execute the code for this problem when we have these 5 items and the capacity of the knapsack is 15. So our answer in this case should be 15. So the maximum value we can get in this case should be 15, and we should include all the items except the first item which have weight 12 kg. So let's execute the code. So the maximum value we can get is 15 and we should include second, third, fourth and fifth items. So we should exclude the first item. Now we can solve the 0-1 knapsack problem using recursion. So in the recursive approach, we have the solve method, which is a recursive method. So this is the base case. When the number of items is 0 or the capacity of the knapsack is 0, we return 0. And if the weight of the item is greater than the capacity of the knapsack, we exclude the item. Otherwise, we take the maximum out of these two cases, when we exclude the item or when we include the item. So let's execute the code. So we get the total value as 11. Now the problem with the recursive approach is that it solves the same subproblems again and again. So the runtime complexity of the recursive approach is big O of 2 raised to power n. So dynamic programming approach is much better than the naive recursive approach. And that's all about the 0-1 knapsack problem. And you can get the code from here.